Hello. Cool. So this is very exciting. Go conference in England, UK. I'm going to be talking today about building APIs. I'm just going to get straight into it. So a little bit about me. I've been coding since I was 6, apparently. I used to copy code out of magazines with my dad. I've been doing Go for quite a long time, and I'm in love with test-driven development. I don't just love it, I am actually in love with it. Especially when it comes to APIs, and I'll get into that a little bit. I then, therefore, founded Testify, which is a testing framework thing that gives you, assert this, assert equal, assert not, all that stuff. I just joined Grey Matter, which is a company in LA. It's a big data thing, which Go is perfect for, by the way. And I was author of Go Programming Blueprints, which is that book, which is still available, and it's had some great reviews. This is my favorite. Reading it now, thanks. Still, 5 stars though, so. Okay, building APIs, cool. Well, what do we mean when we talk about APIs? Well, everything's really an API. All these things are examples of APIs. Whenever a programmer is using your stuff, that's an API. But I'm really today going to talk about web APIs. So why use Go for a web API? It's extremely quick, and you can get things built very rapidly. And it's not just a scaffold thing that you're going to throw away later. You can build things that are actually production ready. And there's an example of some real, that's it. Apart from the imports and the package name, that is it, and it's running, if you can see that. So you can do real things quickly, and it's production ready. Go is getting more and more popular, so it's a growing language, a vibrant community, as we've seen, and this is testament to that also. So it's good. So building APIs in Go, well, the best piece of advice I could give would be to use the standard library for as long as possible. There are lots of frameworks that do very interesting and helpful things. But I would say, as a rule, avoid them if you can, and only use them when you have to. What that means is, when a new person joins the team, or in a few months when you've completely forgotten what this thing was, you don't have anything else to learn. You only just have to use your knowledge of the standard library and the language itself. Use the http handler and http.HandlerFunc types. They're extremely useful and extremely cool. For anyone who hasn't seen this little piece, it's quite mind-blowing and actually feels a bit like magic when you first do it. We have a handler interface at the top, and it implements a single method, serve HTTP, that takes a ResponseWriter and a request. Now, these single method interfaces in Go are insanely useful. If you look at IO reader, IO writer, those types, they are the same. They provide one method that you have to implement in order to satisfy that interface. And they've also added in there the HandlerFunc type, which is a function that kind of mirrors that serve HTTP method. And this is where it gets cool, because in order for you to use a HandlerFunc as a handler, they've implemented that serve HTTP method that just calls the HandlerFunc function itself. So it feels a bit crazy, but what it really means is you can write even simpler code. You don't have to build a struct that implements serve HTTP. You can just use a function, plain old function. And this is a very, remember this signature, because this is the kind of crux of writing web things, particular APIs in Go. So the ResponseWriter is actually quite simple. It's an interface. It has a header on it. You can write to it. And that's actually an IO writer as well. So it actually implements that interface. And then you can also write the header, which is the thing that gets called first, and you set the status code and things like that. And that's really it. And with that, you can do pretty much everything you need to do for standard web stuff. The request is where you get information about the request that's come in, right? It's obvious stuff, this, but I think it's quite useful to point out, and you can see some common things that you'll use there. You have the method, HTTP method you might care about, and there's a read closer. Read closer is the body, so you can actually, that's how you read what's been sent as part of the body of the request. So routing. This is a real thing that you definitely have to do. Routing, what I mean by that is we want to say when there's a get at /things, run this handler. So I'm going to, I want this to handle this thing. And there are some real examples of saying, I'm going to handle /hello with the hello handle. And I'm using HandlerFunc, which is I can pass in just HandlerFuncs. So it's the shortcut version of I don't have to build, a full type. And again, if you can get away with just using the standard library, then do. But there are some gotchas. / matches everything. So that thing at the bottom where I say HandlerFunc /handleindex, if you did a get on /monkey, it would also handle that with handleindex, which you don't really want. It's a little bit confusing. There's no path parameter parsing in the standard library, so you have to do that yourself or use a package. So that's, if you have things /id, that's how you would access that. You'd want to be able to break the path up and to access it. And there's one handler for every HTTP method. So if I did a get on /hello, it's the same as a put on /hello, which is okay, for simple cases. But if you're building RESTful APIs, then it's sort of not really okay. And there is a great package for this. If you haven't seen this, Gorilla's Mux package lets you do this. You create a Mux router, and that is an HTTP handler. So they've used this interface, the interface that I pointed out earlier, which means then we can actually pass it in to the handle method of the HTTP handle function. And I'm saying here, handle everything, basically, with this router. The lines I've highlighted above that are, sorry. This is how you can do some more interesting things other than just routing normal things. You're able to append methods onto the end. So I'm saying here, if it's a get at /things ID, then send it down to the handle things read function. If it's a put, send it over to the handle things update. And you can see that there's use this curly braces to put the ID in the path, and the package will parse that for you. So I just access down here in my handler, mux.vars, give it the request, and it gives me back a map of the path parameters. And then I can just say, vars ID, and then I get my ID. So it handles that stuff for you. There is also another one, HTTP router, which is quicker, actually, performs better than this, but breaks the serve HTTP signature, breaks that interface. And I think preserving that interface is important. And there's debate, for sure, on this subject. We'll dig into that again. So you're going to want to respond with some data, right? So there's a request that comes in, and you're going to respond with data. You're going to do that probably quite a lot. So I recommend having a function that you use all over the place, really. Take the ResponseWriter and request as the first two arguments, and actually mirroring that pattern makes it really obvious that this respond function is responding to web requests. And you can take other things too. So in this case, we take the status and the data, and we then do our responding inside that function. What's nice about this is you can keep it really simple, a bit like that, until you need to make it more complicated. I've ever built things that speak JSON. I don't see any reason why you would use, what's the other one? XML, remember that? So JSON works, and I think it's good. But you could, in here, look at the request. Maybe there's something specific in the request that says, I want to change this a little bit, so can you give me something a bit different? Well, you can do that later. You don't have to do it up front and without touching the interface. And I did actually do this as a package. So this breaks the rule that I've just stated, which is don't use an external package. This was common enough for me to do this. It's just open source because that's just a nice thing to do. It's basically that same function. It has respond.with, and then you pass in the arguments, and it does the responding for you. It has a few other bits and pieces built in, and if you're going to roll your own, you probably will end up doing something like this. You can actually specify these respond options when you come to... You can do this later, so you can just use normal respond with throughout your code, and then you can add this after, and it uses a wrapper, which you can see at the bottom, that wraps your handler in these options. So you can kind of do the options after the fact. And it just lets you do things like, OK, on an error, we're going to do this. Before is an interesting thing. Before you respond, give me a chance to tweak something, maybe. In this example, I set the header. So that's a header that would be set on every response. And I also check to see if data is actually an error. Because if you use the JSON marshaller to turn an error into a JSON, you just get an empty little object because error is an interface. It doesn't actually have any fields for it to marshal. So in this case, it checks and instead changes what it's going to respond with by just returning it. And it builds a little MapString interface there with error and sets the error on it. MapString interface, by the way, I don't know the level of how familiar we are. I'm going to assume we've sort of got a broad range of experience. The MapString interface you can think of like just the normal kind of generic map that Go uses. It's a string is the key, and then that interface with empty things basically means everything, since everything's going to implement that interface, which is kind of cool. And another example of how, just using the language, you can be expressive in this way. And then there's an after as well, but you get the idea of that. There is a cool pattern, something we ended up using quite a lot, which is this public pattern. So again, single method interface, because we love them. There's a public method that just returns an object. And in our respond code, we're doing this little trick here to say, if our data implements that public interface, i.e. has a public method, then we're going to change the data and use that instead. That's useful for if you have down here in the example, you have a user struct. It's got things in there that you might not want to expose. So you can just give it a public method, and instead, that's what will be written out by the respond function. So you can start to build these little mini patterns in your own code, and you don't need external packages to do this. That's basically all the code you need in order to do that, and it's quite expressive. You're going to definitely need to decode data from the request. This is where a client has posted a JSON blob or something to say, here's the new object I want you to create, or here are some options that I want you to do something with. So having a single decode function is also useful. It seems quite obvious, but what you'll tend to do is see that JSON new decoder decode line just everywhere. And putting it in one place does a few things. It's dry, so you're not repeating it, but it also lets you do something quite cool when it comes to validating the data as well. And this is one we call the OK pattern. There's an OK interface, a single method interface, and just has a single method on it, OK, returns an error or nil. So the idea is a struct is going to implement that method, and you can call it, and if it returns nil, you know that the object's OK. If it returns an error, then that's something's up with it. And it's a really neat way of doing validation for incoming data, and actually any kind of data. And then you can expand your decode function to check. So we say, if this value implements the OK interface, then I'm going to just return that. That's going to be something that I do before continuing. And so here's a real example of that. I've got a gopher at the top, and we have an OK method. And this is just going to check the length of things and returns an appropriate error. Or if everything's OK at the bottom, it returns nil. And then this code doesn't change, but this is just how you would use your decode. And it's quite expressive. It looks, it's quite simple what's happening in there, I think. And it's clear to read. You're saying, here's a gopher, decode from the request into it. If there's an error, then it's bad request response. Otherwise, it's an OK, and here's the object. So different type for new things. This is another thing that kind of stumped us for a while. In Go, you tend to think of, and actually it's just a general OO thing, really. You tend to think of, you have one object that represents a thing. And we found out that's not actually really the case, because they're different. A new Gopher, something being created, this is like a user in this case, that's different to an existing one or one that lives in the database. So it's fine to have them as different types, and it's actually really quite clear. So the new Gopher type has password and password confirm, and the Gopher type has instead a password hash that would be generated. And you can see that that's not included in the JSON output. These JSON tags, they're called tags, and they basically, using reflection, you can find tags that relate to fields. So that lets the JSON package, it lets it know how we want these fields to be known, or what we want them to be known as. And there's a few little bits and pieces you can do there. And it's quite an interesting little feature of the language that's kind of one of those little strange ones that feels actually a little bit out of place in the beginning, but you do get used to it. And I think it's quite clear again. It's quite expressive. You know what we're saying there. Now, the other cool thing is if you do have a new Gopher type, or you have a new thing, you can actually have your, if you want, save method on that new thing, and it returns the concreted thing. So then you kind of encapsulate where you're going to put that. And you might decide to give it a database and say, save it into this database, or maybe you'll do something slightly different, depending on what you want to do. But what's nice is you could also employ the OK pattern here to validate that password and password confirm are the same, and if not, return an appropriate error. And then, of course, when you try and decode into new Gopher, if they've set the password and confirm if they're different, it's going to catch it and return. So, writing middleware. So this is actually probably the most fun you can have doing Go, I think. There are packages that do this too, but I genuinely don't think you need them. And this is a case where I think they can be avoided. What's happening here? This is potentially a little bit weird, but a little bit like we saw the HandlerFunc thing implementing the interface and kind of calling itself. All we've done really is the decorator pattern or the adapter pattern. We wrap this handler and return a new HTTP handler, and we store the handler that we're wrapping in this wrapper type. So it's quite simple. When we then when serve HTTP gets called, i.e. a request comes in that's going to be handled by this handler, we get an opportunity to do something before and after the actual handling happens. So we can wrap this, we can wrap it up. And it's as simple as you get to just call wrap and pass in the handler, so you can be quite expressive there too. And I'll come to a real example of how you can use this, and a few other things too. So don't break the interface. This is lots of people do this, where you have a function, and it looks like this. It has a database session, it has a logger, because maybe your thing needs those things in order to do its job. That's fine, but I prefer keeping it simple and sharing data with other means. And we also have done this one to quite good effect, where you create a server type that encapsulates some of the things you need, and the handlers live off that type. So then you can access, through this S variable, you can access the things you need. That's OK, but it's not great for if you're doing common tasks again and again, like in a database, if you use the Mango, to connect to MongoDB, you copy the session. So you dial the session initially, copy it, and you use that copy for your request, and then you close that copy and clean it up, leaving one connection always open while your program's running. And that's the example I'll show later. There is a serve HTTP method on here too, because then suddenly your server is the thing that you can just say, give it to your router, or give it straight to the HTTP handle method. Sharing data across handlers. So if you aren't going to change the signature, you need a way to pass data around between your handlers. And again, the Gorilla do a great package called context. And context doesn't break the interface, so you can have whatever signatures you like. So I get to have my simple, familiar ResponseWriter and request pair. It provides a MapString interface per request. So for a new request, you get this little bucket that you can just store things in, and at the end, it gets cleaned up for you. If you use this, it actually has a wrapper as well. It uses the same pattern, and I'll show you an example of that. And then you just use context.get and set to save things that you want to pass around. So somewhere you might have this prepare something function that sets the logger, and then when it comes to handling, you can get the logger back out. It doesn't seem, very useful in this context, but there is a real-world example where it makes more sense. So this is the database thing. It's very common if you're writing kind of database code, and really it's hard not to. What we need to do is connect when the program starts, dial our database, create a session for each request, tidy those up, and then when we've finished, when we terminate our program, close the connection. And we can do it with a MongoDB wrapper like this. And so the function at the top is with DB, and you can see that it takes the database session that we would have dialed. It also takes a handler. So we're wrapping this handler that we pass in, and we return a new handler. So it's that same thing of taking in a handler, decorating it or adapting it, and returning a new one. And we pass around the http handler type, which is that really simple interface. And that means anything that implements that type can be used throughout this code, which is really the power of interfaces, and particularly the power of single method interfaces. So we have a DB wrapper. We keep the session, and we keep the handler in this struct. And then you can see here our DB wrapper has a serve HTTP method on it, and that's how it's okay that it's an HTTP handler. If we took that off, we'd get an error because it would say you can't return this DB wrapper because I'm expecting an HTTP handler. It needs to have this method, and so there we have it. And so that's going to be called that's going to be called whenever some routing decides this thing's going to handle this particular request. And then inside there, since we have the mgo session, we'd make a copy of it, and then we defer the closing of that session. So straight away, we come in, we create a copy of the session, and if you don't know the defer keyword, it's great. Swift recently kind of borrowed it as well. Essentially means run this code when we exit this function. And people think immediately, well, just put it at the bottom. But there's often lots of different ways of exiting a function. There might be an error, so you're exiting early. You still want to close that session. And then we put that session using context, we put it into the context for that request. So, and the key is DB, so we can get that later. And then we just serve the request. We call the handler that we passed in initially. We then call it serve HTTP on that and give it the chance to serve it, knowing that there is a database available, a database session available for it. And this is how you use it. And this is this is it. This is all you need. We dial the database at the top. I didn't bother with error checking, but always check errors and handle them. I did this just because I ran out of space, because normally I would have left it, because I think it's really important. In fact, there is one in there too. So we dial our database and defer the closing of that. We then create our router. We set up things we want to do, and this one we're actually saying, when it's /things, I'm going to wrap my handler with DB. So we pass in the handle things read handler as our thing we want to wrap, and we give it the database session. And so we know that it can copy that, and make that available to our handle things read. And then here's the line where the context is getting cleared. And this is the same principle, actually, wrapping an HTTP handler. We're saying, context has a clear handler method, which is going to tidy everything up for that particular request. And then in our actual handler, we firstly get the session that our withdb function popped in for us, and then we use it, and we have access to it, and we don't have to change our signature. It's still the same pair, ResponseWriter request. So what's actually happening then? Okay, well, the client comes in, it says get /things, /things apparently. The router then passes that to the withdb thing, since that was the first thing that I gave it. Withdb copies the database session and stores it in the context. It then calls the wrapped handler, handleThingsRead. HandleThingsRead then gets the database session from the context and uses it, and then responds. And then execution passes back to withdb, where we deferred that close statement. So then the session gets tidied up for that request. And then the clear handler tidies up the context for that request. And what's nice about this is I can nest many things in this. I don't, if I say withdb and then I've got maybe there's an auth check and there's another thing, you can actually wrap these things all the way down, and it's just HTTP handlers. Which leads me to this adapter interface, which is very interesting. And this, I'm not sure, it's definitely possible in other languages, but it's definitely not going to be this expressive. So this is another place, I think, where Go really shines. It is a bit weird when you first see it, but it's essentially a level of abstraction above what we just did. So you say, there's this idea of an adapter, and it's any function, excuse me, any function that takes in a handler and returns a handler. So then, here's an example, our logging. I create a function called logging, and it returns an adapter. So the adapter is a function. So it's going to return a function. And that function, when we give it a handler, is going to wrap it and return a new handler for us. It's going to adapt it. So then, that's what I'm doing here. I'm immediately returning a function that matches the adapter interface. And when that function gets called, I then return another function that does the actual work I want to do. And again, it's the familiar pair of ResponseWriter request, and I get to do things in the same way before and after I actually call the underlying serve HTTP. So now we have this adapter concept, and it means that we can do cool things like this, where we have an adapt function, where we say, I'm going to give you a handler, I want you to adapt it with all these adapters that I've written. And it just, you can see here, ranges over the adapters and calls the function, calls the adapter function, passing in the handler, and then keeping the handler that gets passed out. And then that's what it returns. So here are some actual examples. The logging one was a real example too, by the way. We have essentially what's happening is when the request happens, we get a chance to call print line on the logger, and then we pass the execution on. There's some other things you can do too. You can say with header and key in a value. And it's okay that the adapter, the function has its own arguments. It makes sense because each one's going to be different. You're telling it to do a different thing. But it returns an adapter. And it relies on a closure to keep the state. So it remembers the key and the value for you because that's sort of part of the environment of this, this function. And this one, you can see here, same as the one before, adds the header and then passes the execution on to the underlying handler. And here's another one that supports the XHTTP method header. So this is a request header now. If that's set, it'll actually change the method before then passing it down. And you can compose these in any way you like. If you use the adapt function here, you'd just say adapt this thing, and it could be your server. It could be your whole thing. Adapt it with all these adapters, and it will do the wrapping for you and create that. And here's a real example of that. So we can adapt a single handler for a specific path. That should probably say like things. So we're saying handle/things, and I want you to use my handler type and adapt it with header in this case, and then something, I'm setting that. And so what will happen is the with header adapter will return. It will return a handler that's wrapped in that adapter. And so you can do other things too, like you can just chain them up like this and say, I want you to adapt the whole router, so adapt everything, and I want you to support this XHTTP method override. I want you to set this general header, and I want you to log to this logger. And all that without really, in fact, without at all touching the interface of our original adapters. It's a very cool kind of technique. And once you're familiar with it, it really starts to shine. It's a really expressive and quite a powerful thing. And I think quite easy to read too, which is part of one of the key concepts of this is you want to be able to give this to a new programmer, somebody that's not worked on the project, and just by the fact that they can do Go, they know what it is. They know what it's doing. A couple of other things. A little bit left of field, but important. Use flags for environment configuration. So this really applies to any Go command line tool or thing that you're building. But do it from the beginning to save you the hassle of having to go back and retrofit this. There's a built-in flag package, so again, part of the standard library, which is great. And it allows you to specify this and say, okay, so my Mongo address is a string, and calling flag parse will parse that from the arguments of the command, and then it makes it available. And then, if you're Dockerizing it, you can set it in your run line in Docker or whatever. You link it. It's a great way to marry things up without binding it too tightly. You see in the example earlier, I just put localhost in there, which you really shouldn't do, even if it's Dockerized. Especially if it's Dockerized. So testing. Quick question: who writes unit tests? And keep your hands up if you write unit tests before you write your actual code. So a few hands went down, but that's still great. I do this because it does lots of things. And I originally submitted a talk on TDD, so an hour on TDD, maybe not, but it is that important. So quickly then, quick recap. Great tests just test one thing. If that thing breaks, then only that test should fail, if you can. That's sometimes difficult because maybe you're relying on something maybe we have the XHTTP method override and we're using that in our tests. Well, if that breaks, then all of our tests are going to break because it's part of the critical path of everything that's happening. But where you can, make only one thing fail, because it then points to what you've done. It points to what the problem is. It should be repeatable. You should be able to just keep doing it. In fact, that's the value of unit testing, and you can get it to, in most editors on save, get it to run your entire test suite and things. And since Go runs extremely quickly and builds quickly, you can do that to great effect. And in Sublime, you get it pops up a little window at the bottom that just says pass or shows you what's failed, which is great. Try not to require any external resources too. That's another thing that's worth doing. So mock things or stub them and pass them around instead, pass some kind of a fake object. There's another cool trick. Even if you're using an external package, say for a database thing or an email sender, you can, if they don't even provide the interface, because of the way Go interfaces works, you can create the interface yourself and say, okay, I'm now saying I've got this interface for an email sender, and just use the method that this thing happens to implement. You can then write your own test one that works in place. So you can do, because of the duck typing, you can do that yourself. So, guess what? The Go standard library provides us a little HTTP test package, which gives us some cool little things that we can use to test our handlers. This one uses the HTTP test new recorder, which essentially implements the ResponseWriter interface, so the W that we were passing around, the first argument we pass everywhere. It implements that, but it doesn't write it to a client or anything. It just keeps track of what happened to it. So we can then call our handler, handle something, pass in the test one, and then at the bottom make some assertions about what happened in there. And I can actually run this. And you can see that it failed because I'm just returning hello world here, not my assertion, which is hello Golang UK conference. Very useful if you're testing single handlers, but what's perhaps more useful is when you're testing the whole thing, the whole stack. And we can do that quite nicely. This is a cool, I love this. This is basically table testing, table tests in Go. So this is just pure Go code, there's no trick. What we do is we define a variable called tests, and we say it's a slice of this anonymous struct type. We don't give the struct a name because we're only going to use it here. We don't need to refer to it again. We say it has a method, has a path, it has the body. It then also has body contains, which is what we're going to say, this is our assertion, and also the status, which is the status we want back. And then there are two real tests. Method, the first one, is a get on /things, and we assert that it should be hello Golang UK conference with an HTTP status of OK. And the next one is a post, and you can see it sets a body and expects HTTP status created. By the way, every HTTP status code is available http.status and then the name. So don't use the numbers, use this because it's easier to read and doesn't require you to be, a bit too geeky. It's a bit too geeky, I think, if you know all the HTTP status codes. That's touched a nerve. So the nice thing about this is there's nothing new to learn. Once you've seen this and you kind of understand it, it's like, yeah, it's just Go code. And the runner is quite trivial. The key bit for the table testing is this. You just iterate over the tests, create a request, and use the default client to actually do the request. And then, assuming there are no errors, read all the body and make the assertions in our test. And this is another feature here of HTTP test, where you can say new server and pass it, guess what, an HTTP handler. So what we then get is this, you get your code running on a real port that you can then hit. And you can see there I defer the closing of it, so once the test's finished, we tidy everything up. And then I use the server URL and add that to the path from my test. So it builds the real URL and makes a real request. So then you're really testing your full stack, including all your adapters if you had any, anything that's happening in that chain, you get to test it. And it's making real HTTP requests, which is cool. Oh, and it's got a run on that. It can't work, can it? Well, it's failing, but because we haven't written the API. But that's sort of the point. So yeah, I'll call that working. By the way, I once worked for a guy, and I was doing TDD, and it was always like he'd see my screen and it'd be like red, because I do red-green testing. So you write the unit test of the thing you want to write first, you see it fail. That's nice because it's evidence-driven programming, right? So you know that you're going to add some value or change something. And then when you do, you see it go green, and it passes, and that's sort of the TDD pattern. If you haven't tried it, do try it, because it's great. But I had this manager who kept seeing all the red failing tests and pulled me into his office really concerned about my performance. So if he's watching, thanks. This is something you can do. You probably figure this out yourself, but you can just have a setup and a teardown if you're doing common things all the time, and keep your server outside of your tests and just make it available. And in order to use it, you then test something. You just set up, defer the teardown, which will run when your test finishes, when it exits, whether it's failed or not, right? Because failure, as long as it's not panic, failure is okay in this context. And what's nice about this is you don't have to use the same setup method every time. You could create the server yourself. If you want to do something slightly different, maybe your server has some configuration in there that you want to change or modify. And that's my kind of rundown on building APIs. I want to do a quick shout out. There's a lot of talk about the community, the Go community, and I think what's really important, the tech community has, for some reason, there's a problem, something's going on where women aren't properly engaged in the tech community generally. And there's a few guys, womenwhogo.org, they're trying to support women in the Go community. The Go community is a great opportunity because we can make it be whatever we want. And we don't have to be the same as the rest of the community. And so I wanted to shout out to them and kind of raise awareness, because what we're doing, if you think about it, is before we even get started, half of the creativity, half of the productivity, half of the innovation, half of the potential is just not playing. That's massive. Imagine what we can achieve if we can get proper engagement from everybody. So that's it. So anyone got any questions on building APIs? We've got 15 minutes, so I hope.
Thanks for your brilliant talk. It was really, really interesting, engaging. I was wondering about dependency injection. So you showed us how you mock HTTP. I was wondering how you handle mocking the database, for example. How do you do that?
Well, Testify has a mock package, actually. But here's the thing. The MGO, the Mango driver, it has a Fluent API. So you actually can say, given this collection, I'm going to load, so it's here. So this makes it really difficult to stub out, because in order for your type, your interface or your fake type to work in place of a real Mango session, you have to be returning real Mango types, because the signature is part of the interface. So this is actually quite difficult to do. So a few options. One, you can abstract this altogether and do something slightly differently, and you have your own kind of, maybe it's an object that is just a things data that can find and add things, and then that can be an interface that you can pass in a fake one and use an in-memory one, things like that. Or you can run it on a real database. I mean, there's something quite nice about your unit tests. Really, it's an integration test, being like the real environment that's going to run out in the wild. There's something about that, but it kind of breaks the rules of just unit testing. You shouldn't need those things. So we've done it before, having our own type, which we tend to get to anyway. I try and avoid like the data objects, data access objects and things, but we generally do end up getting there. Thank you. Any other questions? My book? Yeah. It's on Amazon. It is a bit, I can't say that.
Hi.
Hey.
I was wondering, where do you draw the line between a middleware and an adapter? I'm not sure I fully got the difference. They both do something before and after the request.
Yes, I kind of bundle it all as middleware. I don't. The adapter thing is really middleware, I think. It's in Go, so it's kind of middleware in your program. So I don't really distinguish. But I only called it that for this. I didn't really know of it. I don't really know it as middleware. And it's just as I was thinking it through like this, I thought, okay, so this actually probably is what's happening. And there are also packages that do middleware, which you can find. And some of them break the thing. They break that signature, which is quite, I think, not great. And some don't. Yeah, you can find the packages and stuff, and we'll post this up, and I'll add some other links at the end of it so we can see them.
Hey Matt, it's Bill.
Hey.
Do you ever feel like you're getting lost on where all these things are chained together and then where context is being set?
Yes. Once you've done it, you kind of do it and you sort of leave it. You tend not to change it very much. I don't. But tracing and logging and that kind of stuff becomes important, especially when you're first wiring this stuff up, because, like you say, it's difficult to know what you've wrapped where and how things are happening. One of the nice things is if you use this line here, what we're doing here is we're saying get from the context the database session with the key DB and cast it to, so this is a type assertion. I'm saying it definitely has to be a Mango session. And if there's something missing in there, that's going to fail. And it'll panic and say, I don't have that thing you need. So you can get your attention drawn to things like that catch it. But there is a little bit of trace it out and have a look and see what's happening and see what the flows are doing. But again, integration testing, you sort of, it's working if the tests are passing, if they're good tests. Hope that answers your question.
Actually, you raised another question.
Brilliant.
So there's always this debate around using panic. I mean, I've got my own ideas around it.
Yeah.
So are you leveraging the fact that the HTTP handler catches that panic and will send that 500? Are you catching it yourself? Like, what's your philosophy around that?
I always handle it explicitly. I know some guys in Denver, Colorado, who they happily just panic throughout their code. That's how they do errors in the HTTP thing, because it winds all the way up. And actually, surprised me, doesn't cost anything more than returning errors. Which was interesting when I found that out. So that seems to be a philosophy. Something about panicking everywhere sort of feels a little bit not Go. I love the fact that we have the pattern of the second argument being an error that you get to pass around and sort of handle, and you have to deal with it and things. So I like to be explicit about handling that. And not just letting the system do it. But you can certainly do it, and you would have one of the adapters could be something that catches the panic at the top level, and maybe even looks at what panicked, looks at the type of the thing that was sent up, and does a different response based on that and stuff. So there's definitely a strategy there. I personally worry when I see panics everywhere. I mean, maybe that's just me. Thank you very much. Running about.
You mentioned earlier around test feasibility to generate interfaces when you encounter something that doesn't have an interface and you want to be able to mock it. I've had a lot of debates recently on open source projects around whether it should become much more convention to provide those interfaces as part of your project. In particular, the AWS SDK eventually talked them into finally putting interfaces around it. Do you think that's part of where we should be going, providing the interfaces up front as part of our projects?
Yes, I always do, actually. And in fact, I don't expose the other type, the actual type. I just expose the interface. So you can do that because, you say you've got an interface that is going to send an email. It's just an interface that says send, and you pass in the arguments. Well, I might have my own little email sender type, but I won't export it from the package because it's kind of messy and people don't need to see it necessarily. And they can just work with the interface. So I love having interfaces. There is also the other side of it, which is if you do expose the actual implementation as well, then you've sort of cluttered the API a little bit, and then maybe there's no value in having the interface. But you know, especially these single method interfaces in the standard library are so useful. I always start with an interface, actually how I think I build the interface. There's another cool trick, actually, which you remind me of, which I think people may or may not know. A package in Go is basically a directory of Go files. And you know, you have to have the same package in every file. Otherwise, it's a compile time error. Except, that is, for test files. You can actually have a different package in your test file. And what that does is allows you to write tests as though you are external to the package that you're testing. So you know, if you don't, and it's nice to do, if you don't need to fiddle around with the internals, you can actually see what your package looks like as a real user will see that, and you can use it. And you know, but doing that in TDD as well is great, because especially if you have like Go Sublime, the plugin that shows you the little autocomplete box, because you type your package name, as soon as you hit dot, you see what your package is, and if it starts to look a bit cluttered and things, you sort of want to keep it tidy, keep it neat. So it's quite a nice little trick. But yes, interfaces, I love them. So I'd say always pop them in.
Cool, thanks.
Done? Yeah. Cool. Thank you very much, everyone.